Okay, so what I'm going to do is I'm going to show some measurements off a popular 4-digit price range linear power supply, one that an awful lot of people may be looking at this video may have. Um, I've got this hooked up with a Wire World Platinum power cord, and I made a real high gauge. They want you to use their power cable. The reason for this makes sense actually. It's because it apparently, I haven't taken it apart and looked, but apparently it has sensing. So it has two little wires that do regulation. So I want to use their cable. Anyway, so I made a real high gauge, real low loss connector in order to be able to hook this up to the tester. Okie dokie. So what we're looking at here is right now this is a low level signal, sort of. The supply is apparently capable of doing up to 5 amps, and we're using it at 12 volts. So right now what we're doing is we're doing about 800 milliamps, and we're using a reasonably slow speed, and we're looking at the noise that this is generating. The waveform that it's generating is interesting. It shows poor jobs at doing stuff. So let me move this over where we're kind of focused on that. Okay, so what we're looking at is, of course, the pulse that we talked about before, and this is a slow pulse. But you'll notice on a slow pulse, the voltage regulator is doing weird stuff. We can take a closer look at this and see what's really going on. Okay, so the first thing that we see is we see the regulation coming down and not recovering right away, but so that's a problem sort of by itself. But this bump is kind of a little bit unusual. Then it has a real slow recovery from that, and then it does not come back, so it stays lower. That's important. So the regulation doesn't ever bring it back. Once there's a load, it doesn't bring it back, try to bring it back to where it was. It's at a lower voltage. This indicates that the regulator circuit has some resistance in it, and it's not sensing really the right way. And so what's occurring is it's dropping down in voltage at a fairly high level. I mean, this is 38 millivolts. This is 10 millivolts per division in drop. So from a normal, that's 10 millivolts. That's 12, 15 millivolts of drop right there. I mean, every power supply is going to do this to some degree. It's going to drop there's going to be some amount of loss that's going to be involved that the regulator can't compensate for. And so that's what we're seeing here is that, but it's a pretty high level, which is pretty typical of what I see on these, fancy linear power supplies. So, but the regulation is very poorly controlled, even at low frequencies. You can also see on the other side, let me flip over to where we're really focusing on this other side clearly, and we'll stretch this out and take a look at this. So here what we have is kind of a little different. So when it turns off, there's a sharp spike initially, really quite sharp, that occurs with actually a little bit of ringing even involved. See, so this is the ringing, this is the snap and woo 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 that occurs. But then there's this uncontrolled slow response that occurs. So then what happens is it deviates and gets confused before it gets back to the right voltage. So there's clearly, this is a typical result, and this is, in my opinion, quite unacceptable in a high-end power supply. I'm got the power supply so we can't really see that because I don't want to call out anybody, anybody's particular product. So I've hidden it over here, right? But this is this is typical of a lot of linear supplies. So so now what we can do is we can do some other things. Let's go to a little higher level with it, because this is supposedly good to 5 amps. So let's take this up some in power, and let's see sort of what happens. Well, so now what's happening is, we're now at 2 amps. So we're halfway to its full rated amount, and we're getting some pretty weird stuff that's going on here. These pulses, this overshoot and undershoot of regulation have gotten pretty impressive, and it's drawing an awful lot of current. It's not controlling what's going on right away. So there's some real odd stuff. Oh, whoops, hold on. Forgot, I need to change my direction there. And then we'll go take a closer look. And so there's some strange stuff going on here. When it first turns on, when the load first appears, there's a really, really sharp spike here that occurs. It's kind of flattened where the regulator goes, ooh, well, there's a lot going on in the curves, and so it doesn't do so well. And that's an 87 millivolt mess just right there. So then on the other side, let's just look at the other side. Well, I should have just worked on the other side, but no. Oh, da-dee-da-da. Okay, so let's go look at the other side of this waveform. All right, so the other side of this pulse, what we get when it turns off, it's a little hard to follow here, but when the load goes away, we get, again, the regulation comes back. That's not too bad, actually. That's at least some kind of normal curve. That's not too much of, and it comes back to where kind of it needs to be, which makes sense. But the problem is that it then varies a whole bunch over time. So this type of behavior isn't a good thing. So let's go up in frequency now. So let's take a look at this. This is at a really low frequency. This is like 100 hertz kind of equivalent. So we're going to jump up to 1 kilohertz kind of equivalent. So now what we're going to do is we're going to go look at this. We're going to look at this pulse, 500 microsecond pulse. Okay, so now what we've got is it's kind of the same thing, kind of a little slower, might even be, kind of a little bit better regulated, but the overall noise is 120 millivolts now. So let's continue to go up. Let's go to like a 500 or a 5 kilohertz kind of equivalent. Okay, now what's happening is it's starting to draw current in a strange way, or to handle current in a strange way. So it's not providing the juice as needed. It's actually, it kind of overcompensates and then kind of drops. So it's not providing the power evenly. And, we're getting, we've now up to 101. So we've dropped a little bit in our noise from what it was. So let's go up to 10 kilohertz equivalent, which is about 50 milliseconds. And that's a strange one. So there's strange stuff going on there, and that's pretty much the limit of where we can get to. After this, it's all just going to kind of go away. So that's one example. I'll go ahead and set up another example, but I guess what we can also do is let's look at it at a really low level. So now we're going to go down in current. We're going to go to a much lower level of current. And see, now it's quite different. Now it kind of looks fairly reasonable. Well, it's a little weird. It's got some ringing, but not too horrible. And then if we go down in frequency, this will become a little easier for it. But then we start to get into that regulation problem at the lower frequencies where it starts getting a little weird. And if we go quite a bit down in frequency, and you can see those those curves are very a particular frequency. So there's somewhere in this power supply where it's kind of a resonant area where it's going to have different kinds of noise. So these are all things that are different about power supplies. I'm going to do one of these to contrast that with mine, to show sort of what we're doing. The important parts when we switch over is to note the noise levels. So we've got 26 millivolts peak to peak and like 5 millivolts RMS noise from this. And this is on a 600 milliamp signal at about 5 milliseconds. Anyway, we'll switch to the other supply.